Okay, here we go. All right. So, again, complementary angles add up to 90 degrees or pi over 2 radians. Supplementary angles add up to 180 degrees or pi radians. So, if I want to find the complement, and we'll just abbreviate that, if I want to find the complement of pi over 5, well, let me back it up a moment. If I gave you an angle of 40 degrees, then to find the complement, wouldn't you do 90 degrees minus 40 degrees? Right? Isn't that how you do it to get 50 degrees? And to do the supplement, you would do 180 degrees minus 40, which is 140 degrees. All right. Now our angle was given in radians, so do not switch it to degrees. We're not going to do that this year in pre-calculus. So I'm going to actually take, instead of 90 degrees minus the angle, I'm going to take pi over 2 minus pi over 5. Now we're going to have to do some fraction work here, and I'm going to have to build common denominators. And so this would be 5 pi over 10 minus 2 pi over 10, which is 3 pi over 10. Now to do the supplement, instead of 180 minus the angle, I'm going to take pi minus pi over 5. Well, I need a common denominator in order to do this. So I multiply by 5 over 5, and I get 4 pi over 5. Okay, in example 3, it says sketch each angle in standard position. Standard position just means you start at the positive x-axis. And something I like to do before I even begin, especially when there's denominators, there's fractions, is I like to ask myself, is this more than one time around or less than one time around? How would I know if it's more than one time around? 2 pi, like, is it greater than 2 pi? Okay, one full time around is 2 pi. So if I think about it, okay, well, with 13 pi over 6, I don't know, looking at that. So I need to think about what would 2 pi be if I had a denominator of 6? Wouldn't that be 12 pi over 6? Oh, then do you see I can tell pretty easily that's more than one time around, but how much more is it? Just 1 pi over 6. Oh, well, I know where pi over 6 is. So let's make a little grid here. And so here's pi over 6. That's 30 degrees. But to indicate that it went more than one time around, do you remember the little arrow? And going around like that. Excuse me. 3 pi over 4. Look at your circle. What quadrant is 3 pi over 4? It's in the second quadrant. And remember, I want you to take a moment and look at your circle again, okay? Notice that the 45-degree reference angles were pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. They're all odd pi over 4s. So, I mean, you should be able to give a decent... It's about halfway in the second quadrant. Now, negative 2 pi over 3. Let's pause a moment. What is, look at your circle, what's 2 pi over 3? 120 degrees. But it's a negative, so I am taking into, here's negative 90. Negative 120 is about 30 more degrees into that third quadrant. So do you see how I figured that out? All right, convert from degrees to radians. To convert from degrees to radians, you're going to multiply by pi over 180 degrees. On A, B, C, and D, do not use your calculator, okay? Only E can you use your calculator. Let me show you how I expect you to do this. you're going to multiply by pi over 180 degrees. You need to be looking for things like 30-degree multiples, 45-degree multiples, 60-degree multiples, and 90-degree multiples. 60 goes into 180 3 times. 60 goes into 120 2 times. That's 2 pi over 3, and I did not have to use a calculator, okay? Now, try B, C, and D without the calculator, and do E with your calculator. Use your unit circle as well. Look at your 45-degree ones. It was 45, 135, 225, 315. Those have really got to become very familiar to you, that you can recall them. Now, in letter E, I don't want pi in the answer. Okay, when you have a decimal, then that's going to indicate you're going to type pi in. All right, check it up here with my answers. Is that, you guys got it? All right, let's go on to example 5. To convert from radians to degrees, and you remember we did this last year, so this should not be, so far we haven't really done anything new. We're just trying to remember it. You're going to multiply by 180 degrees divided by pi. So let me do the first one with you. You would take 5 pi divided by 6 times 180 degrees divided by pi. So I cancel the pi's, and then 6 goes into 180 30 times. I need to give you a word of caution here, because I'm not, in no way am I trying to nitpick. Okay, sometimes I do nitpick, but this is not one of those times. If you do not put a degree symbol, it is assumed radians. So on a quiz or a test and you're asked for the answer and you put 150 with no degree symbol, it's going to be marked wrong because it's not 150 radians. Okay, it's very, very important. All right, then in number 7, this one, B and E, you have to do with your calculator, because you're going to take 7 times 180 and then divide that by pi, and I get 401.07, that's degrees. I'll give you a head start. Do C, D, and E. And you guys, if I'm going too quickly for you today, you can watch the lesson again on YouTube. I had an Algebra 2 student tell me today, yesterday we were doing end behavior graphs, you know, with our arms and stuff, and she said she was a little bit lost in class, and she went home last night, watched it again, and then she thought, why did I think that was difficult? You know, but it was sometimes just needing to see it a second time, okay? So don't forget that you have access to it. All right, any questions on example 4 or example 5? Going back and forth. Pretty easy? All right. This next definition is huge. This I have seen on the ACT, and they don't give you the formula. You're supposed to be bringing that in your base knowledge. So it says, for a circle with radius r and a central angle theta, I need you to write a note here. Theta, for this formula to work, must be in radians. And then this S is the arc length. So let's draw a little circle here. If this is r, let me refresh your memory from geometry. A central angle is an angle in a circle where the vertex is the center, okay? So look at example 6. A circle has radius 4, and the angle is 240 degrees. Now I'm trying to be really helpful here. If you take 4 times 240 degrees on the next quiz, it's wrong. What's wrong with taking 4 times 240 degrees?
Not in radians.
Theta's not in radians. So it's a good thing we just practiced converting them. So we're going to multiply by pi over 180, or if you know your unit circle, you already know this one. 60 goes into 180 3 times, 60 goes into 240 4 times. So this is going to be 4 times 4 pi over 3. So S is 16 pi over 3, and that's in inches. Now, keep in mind that an arc length is almost like a small piece of the circumference, right? So if you would happen to forget the formula and you're taking the ACT, you could do this. You could actually figure out the angle is what part of the whole thing and do a proportion with the circumference. Okay? Like, do you see this? You could do 240 over 360 is x over 2 pi r, and then, you know, in this case that'd be a 4. And then do you see how you could do it like that? That really does do the same job for you. Okay, I need you to X out the next 2 examples, but I need to do 2 different examples with you. And I need to give you a definition first. Just do it in the space that's there, okay? Just cross them out. Coterminal angles. We had trouble with this last year. Coterminal angles have the same initial side and terminal side. That means they start and stop in the same location, but if you think about the arms of a clock, you know, it could have gone around, you know, another hour or another hour or another hour, okay? So here's an example. Find an angle that is coterminal with, and in A, let's do pi over 3, and in B, we're going to do negative pi over 8. Okay, so let's think about this a minute. Let me think about pi over 3. Here's pi over 3. A coterminal angle will have the same start and stop. So one of the ways that you can do it is, couldn't you rotate in the negative direction? And that really does have the same start and stop. Not the same angle value, but it really, I would draw it the same way. So in order to get that, you would take pi divided by 3 minus 2 pi. So this is pi over 3 minus 6 pi over 3. That's negative 5 pi over 3. Now the other thing you could do is you could go all the way around plus the pi over 3, right? So it could be pi over 3 plus 2 pi. Now don't reinvent the wheel here. You already did your common denominator, so don't try to figure it again. So that's 7 pi over 3. So let's write ourselves a note. To find coterminal angles, now it matters, you guys. Subtraction, the order of subtraction matters. So it's not 2 pi minus the angle, it's the angle minus 2 pi, or the angle plus 2 pi. So now I can do B without drawing a picture. I can just add 2 pi to this. So that's negative pi over 8 plus 16 pi over 8. So I think in your homework it asked you to come up with one positive coterminal and one negative. So most of the time it's just add and subtract, but sometimes you have to subtract twice and sometimes you have to add twice. So this one's negative 17 pi over 8. All right, yay, I'm going to get to this with you. I ran out of time with the other class. I want to show you something on your calculator. I think I showed it to you last year, but just in case I didn't, we have degrees, minutes, and seconds. And there really is no reason for us to do this by hand. So take out your calculators, and what you'll do, and I'll come back to that, okay? If I would do 178.463, and then do you see there's a, under the apps key it says angle? Do second angle. Number 4 is going to take it for you and convert it to degrees, minutes, and seconds. It'll do it automatically. Now, do you see this one wasn't a whole number, but we would probably just round that to 47. So I'm going to write that as 178 degrees, 27 minutes, 47 seconds. Does anybody know why we would do this? Who might want to know this? Yeah, if you're doing navigation on a ship, uses that. On maps, I think on maps where they're doing their longitude and latitude stuff. Then going the other way, if you want to convert to a decimal, and I give you 72 degrees, 15 minutes, and let's do 32 seconds. Let me show you how you do this. You guys ready? So you're going to type in 72, and then if you do second angle, there's the degree and the minute. So what did I write down? 15. So you do second angle. Now notice, did you notice there's no seconds there? What were the seconds?
You just do
32.
2 minutes.
32? Look right here. Do you see the quotes? They double act as quotes and seconds. Isn't that cool? Okay, so it's right there.